welcome back to the DSA solutions. Today we'll see how to add two numbers from two non-empty linked list. We'll add two numbers and we'll return the sum as a linked list. The two linked list for our input, we'll add two numbers from these two linked list. We'll initialize a dummy linked list for our resultant linked list. And we'll set a pointer at head of each input linked list. Now we'll add values for the first node 2 from list 1 and 5 from list 2, that is 7. We'll add this value to our result linked list, that is 7. Now our result list is 7. Now we'll move our node to next node. So for list 1 head is pointing to 4 now, and for list 2 head is pointing to 6 now. So add the values of first node 4 and 6 for list 2, it is 10. So from result value we'll place the last digit, that is 0, in our result list, next node of result list, and we'll carry over the 1. Next we move to the next node. Now list 1 head is pointing to 3 node and list 2 head is pointing to 4 node. Add the values of the first node 3 and 4 from list 2, and we have carry, we can add plus 1. Oh, it is 8, so append 8 to the result list, and now our resulted linked list is 708. Now we'll move to the next node from each list. Now list contain null node, all list is pointing to null node now. So this is the last step. We can return our result list. There one more example where linked list 1 is having value 957 and another linked list having value 5642. So initially we'll initialize a dummy linked list, that is resultant linked list. We'll take a pointer at the head of each input linked list. So from list 1 head is pointing to 9 and from list 2 head is pointing to 5. So add 9 plus 5, it is 14. So from 14 we'll place last digit of 4 in our resultant linked list, and we'll carry over this 1. So our resultant linked list is now 4. Now our pointer will move to the next node from each linked list. So from list 1 head is pointing to now node 5, and from list 2 head is pointing to now node 6. So add 5 and 6 and we have one carry, so it is 12 now. So from 12 we'll keep last digit in our resultant list. So now our resultant list is 4 2, and we'll carry over this one. Now our pointer will move to the next node from each linked list. So from list 1 head is pointing to node 7 now, and from list 2 head is pointing to node 4 now. So add this 7 and 4 and we have one carry, that is 1. So now it is 12. So we'll add last digit from 12, that is 2, in our resultant list. So our resultant list is now 4 2 2, and we will carry over this 1. Now pointer will point to the next node. So from list head is pointing to node null now, and from list 2 head is pointing to node 2 now. So for easy calculation, what we will do, if node is pointing to null, we will make them like their value as 0. So add 0 and 2 and we have one carry, that is 1. So total is 3. So we can add these three to our resultant list. So our resultant linked list is now 4 2 2 3. Now our pointer will move to the next node. So from linked list 1 head is pointing to node null, and from linked list 2 also head is pointing to null node. So we'll not do iteration again. This is the last step, and we can return this resultant linked list. For coding part, we initialize result with a dummy head node to simplify the addition process and manage the resulting linked list. Current is assigning to result, so we set a pointer current to track the end of the result list where new node will be added. This carry variable will keep track of the carry value that will be used in the addition of each digit. This while loop continue until both input linked list have been completely traversed. This x variable will hold value of the current digit from the first linked list, and y variable will hold the value of current digit from the second linked list. If first linked list is not null, then we assign the current digit from the first linked list to x, or if linked list is null, then we'll keep 0 to our x variable. Next, if linked list 2 is not null, then we assign the current digit from the second linked list to y, else 0. Then we will calculate the sum x, y and carry. So x, y is current digit and carry from the previous addition. Now we will update our carry for next iteration. If you divide a number by 10, you will get a carry. Now we'll create a new node from we'll create a new node with last digit. So how we can get a last digit? If you do modulo with 10, then you can get a last digit. So with that value, we are creating a new node, and we are attaching this to result list. So after the loop, if there are any remaining carries there, we add it to a new node, and we'll add this at the end of our result list. At the end, we are returning a result next value. So we are skipping the initial dummy node 0 for the correct result, and we are returning the value.